Hello student, in previous video we have seen about the definition of the motion, rest, some of the physical quantity, and in that the types of the physical quantity, scalar quantity, vector quantity. Then after we have seen about the distance and then the displacement. And then after seeing the difference between the distance and the displacement. Now in this video we will see the some of the more physical quantity. So let's begin. The first one, that is of a speed. So the speed and the velocity. So the speed means the distance traveled by the body per unit time. Body means you can consider as an object. So the distance traveled by the body per unit time. Any body or any object, the total distance which is traveled by the object in given time, or you can say the per unit time, then it is considered as a speed. So the formula of the speed, you can write down that the speed is equal to distance divided by time. It is a scalar quantity. Scalar means it does not require any kind of direction and it always positive, and that's SI unit, that is of distance means the meter, and for the time it's a second. So the meter per second. Here also you can see in the formula of the distance speed that it requires the distance and the time. So the distance is a scalar quantity. So the speed is also scalar quantity, and as we see that distance is always in a positive. So same, the speed is also always in a positive, and its SI unit, that is of meter per second as per the formula distance per time. So the distance for the distance unit, that is meter, and for the time it is a second. Now the next physical quantity, that is of a velocity. Velocity means the distance traveled by the body per unit time in a given direction. The distance traveled by a body per unit time in given direction. As a displacement, as we see in the displacement, same as in this one, the distance traveled by the body per unit time, but here the direction is required. So in what kind of direction the object is moved. So the distance traveled by a body per unit time in a given direction, so it consider the velocity. So it is a speed with the direction, so velocity is equal to displacement divided by time, because here the direction is required. It is a vector quantity, means for the denomination for the description of the velocity it requires the direction, and it can be positive, negative, and the zero. Means as we see in the displacement, that displacement can be positive, negative, and the zero. So as per the displacement, it is because you can see in the formula that velocity is depend on the displacement. So the displacement, as we see in the displacement, that it is vector quantity, it can be positive, negative, and zero. So same velocity also can be a positive, negative, and the zero. And the SI unit of the velocity, that is of meter per second. Here the speed and the velocity, both the unit, SI unit is the same, but the difference, that is of only of the direction. The speed, it does not require the direction, while the velocity is require the direction. And the speed can be speed is always positive, whereas the velocity can be positive, negative, or the zero. Now let's see the another concept, that is of average speed. How can we calculate the average speed? So the average speed is equal to a total distance divided by a total time. Means for object to cover the total distance, how many time it's required, then we get the average speed. Same like the average velocity, means the average velocity is equal to the initial velocity plus final velocity divided by the 2. Then we get the average velocity. initial velocity and the final velocity divided by 2, then we get the value of the average velocity. So these both are the formula, average speed and the average velocity. Initial velocity means the starting velocity and the final velocity means the object move and at the last wherever it is that is called the final velocity. Now the next one, that types of motion. It is the new topic. According to the motion, it is divided into two types. One is the uniform motion and the non-uniform motion. Let's see the uniform motion first. When a body travels equal distance in an equal interval of the time, then the motion is said to be a uniform motion. Here the body or the object is travel the equal distance in the equal interval of the time. Then the motion is said to be a uniform motion. Suppose here one truck is there. Suppose in the main position, it's the initial position, that is 0. When it is start, then it is start from the 9 o'clock and at the 10 o'clock it cover the distance 100 kilometer. Same like, then after 1 hours it covers again 100 and reach to the 200 at the 11 o'clock. Here you can see at the 11 o'clock it reached to the 200 kilometer. Same like after 1 hour, 1 more hour, it is reached to a 300 kilometer. Means at the 12 o'clock it is reached to the 300. So here the time interval, that is of a 1 hour, and the distance travel equal distance if you are considered, then between the interval of the time, all the distance are equal. Here you can see the 100 distance is covered by the same time interval, means the 1 hour. So if we are draw the graph of this time versus distance, then we get the straight line of the graph. Suppose at the axis and the y-axis, here you can see on the x-axis we are taking as a distance and that the y-axis we are taking as a hour. So we get the straight line graph. Whereas the non-uniform motion means when a body travel unequal distance in an equal interval of time, then it is said to be a non-uniform motion. Means here the interval is same but the distance is unequal. Then it is considered as a non-uniform motion. Let's take one example by which you can easily understand. Suppose here the truck is covered the 70 kilometer per hour at a 1 kilometer. First 1 hour means at the 10 o'clock it is reached to the 70 kilometer. It's covered the 70 kilometer and on the 11 o'clock it reached to the 200 kilometer. So in the first interval it covers the 70 kilometers, while in the second interval it covers the 130 kilometers. So here you can see both the time interval is same, but the covered distance it is a different, and the first interval it's covered the 70 kilometer, while and the second interval it covers the 130 kilometer. So if I draw the graph a distance between the time, then we get the uneven graph. We cannot get the straight line graph. So this kind of motion we consider as a non-uniform motion. When a body travels unequal distance in an equal interval of time, it's said to be a non-uniform motion. Here you can see the graph, it is not in straight line. You can see it is an uneven type. Now let's see the symbols of some of the quantities, physical quantity. So here the first one, that is of a distance. So Distance you can denote it by the capital S. If as that distance symbol, then it is denoted by the capital S. The next one, that is of a displacement. Displacement which is denoted by the triangle shape and with it as capital S. It is denoted by the delta S. So the initial velocity, that is denoted by the U, whereas the final velocity, that is denoted by the small v. Time which is denoted by the t, that is, but it is in a small, so the time is denoted by this t. Acceleration, it is also one kind of scalar, one kind of physical quantity which is denoted by the small a. Now the speed is equal to velocity is equal to v, that we consider in the both the case. Speed also we can denote it by the v, and the velocity is also denoted by the v, but here the v is a capital. So the speed is equal to distance by time. So the formula is equal to, for the speed it is stand v, and for the distance it is stand for s, and for the time it is stand for t. So v is equal to s by t. So these are the symbol of the some of the physical quantities. Now the next one, that is of acceleration. So let's see the acceleration. So, the rate of a change of a velocity of an object with respect to time is called the acceleration. How the change of velocity occur? In that, we have to consider the initial velocity, means the starting velocity, and the final velocity, and for that the how many time is required, that we have to consider. So the initial velocity which is denoted by the u, final velocity which is denoted by the capital V, and the time taken for the changing this velocity from initial to final, it is denoted by the t. So the formula, that is a is equal to v, means the final velocity minus initial velocity, means the u divided by t. So the formula of the acceleration, that is a is equal to v minus u divided by t. So it may be positive or negative. So the acceleration, it may be positive or negative, and the negative acceleration is also known as a retardation, or you can say the deceleration. Means if we get the value of acceleration in a minus, then it is considered as a retardation, or you can say the deceleration. How it is possible? If the value of the v, it is lower than the initial velocity, in that condition we get the negative acceleration. So the SI unit of the acceleration, v and u both are the consist of a meter, and for the time, that is of second square. So the SI unit of acceleration, that is meter per second square. And acceleration, it can measure in the meter per second square. Thank you.